Hi, so in this video I'm going to be demonstrating how to do prep test B game 1. Okay, so for this one we have 8 players, J, K, N, O, P, S, T, and V. Right, and they're arriving one at a time at a dock. They're boats, and so this is an ordering game. Okay, but then all of our rules just state a player's position relative to another player. So T before S, but after J. So this is one where we don't actually have players' positions relative to the board. And we have quite a few players as well. So this is a good introduction to web games. Okay. These are also known as loose sequencing games as opposed to strict sequencing games. This would be a linear game, that's another term that could be used, or a pure sequencing game or a one-line sequencing game. But essentially we have to order them, and all of the rules just tell us relative positions. So the reason I call them web games is because we want to draw a web that connects the players to one another according to their relative positions. So we're going to order them from left to right. Okay, so this will be the one that arrives first, and this will be the one that arrives last. So if T arrives before S, that means T is closer to 1 than S is, right? So it arrives before S. So it's going to show up somewhere to the left of S. But T is after J. So J is before T. Okay. N is also before T. So now I'm just going to actually add N, and because T is already on my board, I don't have to redraw it. I just connect N, and N is to the left of T. K arrives after J, but before S. S is already on the board, so K just has to be before S, and S must be before O. Okay, so that's all of the rules represented, and it's created this little web. I only have 6 of my 8 players represented though. So that means that I have 2 players that are unrestricted, and those 2 players are V is one of them, and who's the other one? We have J, K, N, O, P. Okay, so P and V are unrestricted players. You could call them wildcards or floaters, free agents, different terminology depending on what prep company materials you're working with. But yeah, there are no rules for either of those players. So they can hop in anywhere in this little board. Okay, so one thing that's really important with web games is interpreting the web. And one way to work with the web is to think about each player's range as being restricted by the players that must be before it, so that have direct or indirect relationships where they have to be before, and the players that must be after. Okay, so this will be easier to understand with a little visual exercise. So if I wanted to see what the range is of T, so what's the range of positions that T could occupy? Well, there are 8 positions total. T must have N before, so I'll put an X on the very left end. J before, another X. That's got to be before T. S must be after, and O has to be after S, so there have to be 2 after T. K doesn't have a relationship to T that's known, so K could actually be before or after T, K just has to be between J and S. So we could have J, KTS, J, TKS, and we're still following all of the rules. So one way to decide whether or not T has a relationship to another player is moving away from T in the left direction. We're going to hit J and N. Okay. But then once we hit J, we can't turn around and now involve K. Right? So as soon as we have to change directions there, then the relationship is broken. There's no relationship between T and K. Same on this side. So if we go to the right, yes, S is connected. O is connected through S, right? We're moving in that same direction, but we can't change directions and go back to K. All right, so T could occupy any of these 4 positions. Okay, so if I wanted to know what the range is of positions that T could occupy, it would be 3rd to 6th, right? Anywhere from 3rd to 6th. And the players that could be before or after T are K and our 2 wild cards, P and V. Okay. Now the first question on this game is actually fairly challenging. So I'll do that one, and then I'll leave the rest for you to try again now that you have the diagram. So if N arrived after K, so N and K, you can see this kind of zigzag, they don't have a relationship to one another. So it is possible that N could be after K, even though if we just sort of scan our diagram, N looks like it should be to the left of K. The lines are what we really need to focus on. So if K is after, if N is after K. All right, so K still has to be after J, right? And N must be before T. S has to be after T. And O has to be after S. K has to be before S, which it is, and after J. So yeah, that's what we end up with. And our wild cards will just float around here, and they can jump in before or after any of these players. So what must be false is the question. Okay, so question 1, our question-specific condition leads us to conclude that we have this long string of players. Must it be false that J is the second to arrive? Well, P or V could step in and be first, and then J could be next. There's no problem with that. Must it be false that K is 5th? Okay, 1, 2, 3. So we are actually going to run into a problem there because we have 1, 2, 3, 4 players that have to be after K, and if K is 5th, there are only 3 spots after it. So B must be false. This isn't going to work. All right, so B is the correct answer. N could be 3rd. P and V could be after N. O could be 6th. P and V could be at the very end. S could be 7th. P and V could be before S. And then O would be the only one after S. So all the other ones are possible. So for a must be false question, all of the incorrect answers could be true. So we can just eliminate the ones that could be true, and we eliminated K being 5th because that's not possible. Okay, so give the rest of the questions a try again on your own, and we can review the rest in session.